the Sky This Month with your host, Dave McDonald.
Welcome to the Sky This Month. I'm your host, Dave McDonald, and you can reach me anytime at astromannh@gmail.com. I'd be happy to answer your questions about astronomy, things that you're seeing, want to see in the night sky. We have a great show, as always. So many things to talk about in the night sky, and events and anniversaries going on. But first, I want to tell you about a special event happening here in Concord. It's the Aerospace Fest, and it's Saturday, September 10th, from 10:30 to 4 o'clock. And this is the McAuliffe Shepard Discovery Center, which is in Concord, New Hampshire. And you can Google directions to that. Exit 15E will be a help off of Interstate 93. But you can see some of the interesting items that we have going on here. So we have the moon. We have, that we'll be talking about, the sun, of course. We're going to have solar telescopes. You see the telescope down at the bottom. And the New Hampshire Astronomical Society will be there with telescopes that you can safely look at the sun. We'll be talking about all things STEM, and you can see a small image in the upper left of the James Webb Space Telescope. Our keynote speaker will be Kelly Beatty, who was a feature on the Sky This Month during our August show, but he will be live and in person as our keynote speaker, talking more about the James Webb Space Telescope at Aerospace Fest. So mark your calendars, try to make it. It's free, no charge for the whole family. Planetarium shows, Mad Science is going to be there with activities, and that is Saturday, September 10th. All righty, so we're in the season of anniversaries. So the first anniversary I want to talk to you about is about the Voyagers. We're in the 45th anniversary of the Voyager season. And Voyager 2 launched August 20th, 1977. And one of the great features of the Voyagers, both of them, there's a Voyager 1 I'm going to talk about in a moment, but you can see on the right side of your screen this golden record. That was one of the key ideas to put on both Voyagers, is this record that has video images of things on Earth, sounds that are on Earth. The directions are on the gold record of how to play it, should some civilization find this record to be able to play it. So, next, Voyager 1. And Voyager 1, you may ask yourself, well, why is Voyager 1 launching after Voyager 2, September 5th, 1977? Well, it's going to catch up and surpass Voyager 2. And there's an image of the liftoff that you can see from the Kennedy Space Center, and then on the right is an image of both. They're pretty much identical twins, Voyager 1 and Voyager 2, on the right side, with a big high-gain antenna and a magnometer that is out on the boom, and it's way out on that boom to not interfere with the signal from the other electronics that are on it. Now, these 45 years ago launched, they are way out there. And next month, we're going to spend some specific time talking about the Voyagers. Todd J. Barber currently works with the Voyagers 1 and 2, and he is the rocket propulsion engineer for NASA, the Jet Propulsion Laboratory. Have you heard of Spirit and Opportunity? They landed on Mars back in 2004. This is the guy. Have you heard of the Galileo spacecraft that went to Jupiter? Have you heard of the Cassini spacecraft that went to Saturn? How about the Juno spacecraft currently at Jupiter? The Curiosity mission landed on Mars 10 years ago, August 5th, 2012. and Perseverance, which just landed last February 2021. And this is the guy that gets these things to their destination. And we're going to be talking with him next month. And our focus will be about the voyages. What are they doing? How long will they last? What are the great findings that we have? And why are they so important? And where are they now? So you want to be sure to tune in for the sky this month, October 2022. Well, another anniversary we have here is the 60th anniversary of John F. Kennedy's great speech, "We choose to go to the moon." And he talks about, we chose to go to the moon and do these other things, not because they are easy, but because they are hard. And what a great inspiration for our young people in school. You don't want to just take things easy. You want to be challenged. You want to go beyond. You want to have to use your brain. You want to be able to have to figure things out and solve problems. And that keeps your brain active and alive and problem solving. And that is a very good thing. So an amazing thing happened, as you may remember, some of you, but hopefully at least from history. May 5th, 1961, Alan Shepard, first American to go up into space, went up, came down, suborbital flight, 15-minute flight. And from May 5th, 1961 to July 1969, we're talking 8 years and a couple months. We went from just figuring out how to put a person up and down on a ballistic missile to walking on the moon with Neil Armstrong and Buzz Aldrin. Mike Collins, so important, orbiting the moon, and brought everybody home in 8 years. It's been so long since we've been to the moon. 50 years. We come up in December this year, 2022, will be the 50th anniversary of Apollo 17, which was the last Apollo mission. Gene Cernan, the last human being to leave a footprint on the moon. So we've got Artemis cooking. And Artemis, at this recording, hasn't blasted off yet, but hopefully it did. It was slated to blast off and launch August 29th. And hopefully that all went well. And it is taking the Orion space capsule, which is the capsule that will be bringing live human being astronauts to the moon. But wisely so, we're going to start with taking the capsule, the same capsule that's going to take the astronauts, 4 of them, to the moon. We're going to see if everything works the way it should before putting humans on board. And this mission will have the first woman to walk on the moon. It will have the first person of color to walk on the moon. And if, again, this will be subsequent to this launch here. So we look forward to the Artemis mission, and hopefully all the testing will go well. And I believe at the moment it's 2025. We're hoping to once again have people on the moon. So we went from nothing to walking on the moon in 8 years back in the 60s. How long is it going to take us now with all our new technology? Kind of an interesting question. So think about that and have a nice day. Well, October 4th, I want to mention it now. I will, of course, again in the October show. But just so you don't miss it, October 4th is when it all started. 1957, 65 years ago, Sputnik launches. And Sputnik goes up into space and changes everything. The space race has begun, and the Russians had the first objects up there. They had the first live being to go be launched, Laika, a dog. We followed up with him, the chimp. And they had the first person to go up, Yuri Gagarin, and he also orbited. And then we had, weeks later, Alan Shepard went up, but he didn't orbit. We had to wait until 1963 with John Glenn before we orbited Earth. And so we got the ultimate prize, though, first to land people and walk on the moon with people, Neil Armstrong and Buzz Aldrin, and bring them back to Earth safely, just as President Kennedy outlined. So it happened. Well, in the news these days is the James Webb Space Telescope. And here you see a model. This is not the telescope, but this is a full-size model of the James Webb Space Telescope. And you can see all those people that had a part in working on it and how big this telescope is compared to the human beings that are there. I had an opportunity to see this model in Baltimore, and it was just amazing to walk underneath it and to just see how huge this space telescope is. And you can see there pretty clearly the 5 layers of very thin fabric as the heat shield to keep the heat away from the telescope itself. And last month, during August, Kelly Beatty brought us some of the amazing images and talked a little more deeply about what the information is that we can glean from those images. I hope you enjoyed that. And again, Kelly Beatty will be at Aerospace Fest in Concord at the McCall Shepard Discovery Center, September 10th. Well, more of the latest images here. Here you can see this was actually a trial image. This was not an intended deep field for scientific research. It's just like, hey, let's take this out for a spin and see what this baby can do. So have a look closely at this image. You can see those black dots in front of the white light circles. Those are stars that are in the foreground. Those are stars that are in our galaxy that just happen to be lined up with where the telescope aimed and took this photograph. But everything else, apart from those several star bursts there that you see with the black dots in the middle, everything else from the sizable ones that you can tell, those are galaxies, to the pinpoint specks of light are galaxies. And we did this in a matter of minutes, whereas the Hubble Space Telescope took months to take its deep field. So really exciting, the capabilities of this telescope. And then recently, last month, we aimed the telescope at the planet Jupiter. And what we see at the planet Jupiter is an infrared image here. So this is, I think everybody can tell that's Jupiter, but the color scheme there is not the same as the color scheme I'm used to seeing there. You can see the great red spot, but is very light in color. And you can see the belts, and also very prominent in this image, you can see the aurora at the northern hemisphere, and at the southern, I shouldn't say hemisphere, the North Pole and the South Pole of Jupiter are very prominently displaying the aurora there. And in this image here that you can see, you can make out the rings. Because when you're asked to name the ring planet, well, everybody thinks about Saturn, of course. And then Uranus and Neptune have rings. But it took the Hubble Space Telescope to find, oh my goodness, Jupiter has rings as well. And so without breaking a sweat, James Webb Space Telescope aims, takes a picture, and there's Jupiter with its rings. So looking a little more closely here, I've named these for you, or NASA did. I'm showing it to you. Thank you, NASA, for the image. And you can see where the rings are. And then you have Amalthea and Althea. These are two moons of Jupiter that kind of keep the ring system, they're part of what helps keep the ring system in order and doing what it's supposed to be doing. So pretty neat stuff in terms of those images and those details that we're able to see at Jupiter. And again, the color variation is we're not taking visible light pictures because, again, one of James Webb's claims to fame is its infrared instrumentation, which gets the heat signatures. And the nice thing about that, as we think about deep space objects to photograph and to analyze, it cuts through gas and dust. Well, guess what's happening in September? Everybody knows. It is the autumnal equinox. The equinox happens this year, September 22nd at 9:04 p.m., and that would be Eastern Daylight Time. Sorry I didn't put that up there. EDT, Eastern Daylight Time, September 22nd, 9:04 p.m. And you can see from the image at the top, that's the vernal equinox in March, but you can see the tilt of Earth is 23.5 degrees. The Arctic Circle, of course, is at the top. And what makes this an equinox is the sun's rays hit right on the equator. So in the foreground, or at the bottom of your screen, you see the equinox, which happens September 22nd to the 23rd. And again, in this case, it's the 22nd at 9:04 p.m., and the sun aims directly at the equator. So if you were at the right place on the equator, right at that moment, the sun would be directly overhead. And that is what makes the equinox. Now, some people claim, and equinox means equal night, which you would think means, well, equal night, equal day. So 12 hours of daylight, 12 hours of nighttime. But that's actually not the case. Because when we are measuring the equinox and the crossing of what we call the ecliptic over the equator, we're marking the center point of the sun. Well, as the sun sets, when the center point is on the horizon, half the sun is still above the horizon and it's light out. Same thing in the morning. When the sun is rising, until that midpoint of the sun hits the horizon, half the sun is already up. So on the equinox, we actually have more daylight than we have nighttime. It's actually going to be September 25th and 26th, but 25th is a little bit closer in terms of seconds. September 25th will be the date in the northern hemisphere around 40 to 45 degrees north latitude, where the day and night times are approximately equal, because we want to measure, nighttime starts when all of the sun is gone, and daylight begins when all of the sun is visible. So that's a little tidbit for you. And another thing that you want to do is you want to get your eggs out, because September 22nd and probably on the 23rd, because the actual timing is 9:04 at night, try balancing eggs on their ends. You need a nice flat surface. You might want to lay down on the floor, or if you have a nice flat counter surface, try balancing egg on its end. And I bet you can do it. So on the equinox, another claim to fame here is at Chichen Itza, and I know that there's supposed to be a accent over the E and the A there on Chichen Itza, but I wasn't able to do that. But in the cultures of the Mayan, there's this dragon or serpent, snake-like, that is Kukulkan. And the Aztecs called it Quetzalcoatl. And this serpent was the god of rain and the wind, a creation type of small g god. And what is neat is you look at the image more carefully, you can see in the right-hand image the shadow. And this happens on the equinox. And this particular picture was in the spring equinox. But the equinox, the sun hits it just so you get that serpentine look with the head of the serpent at the bottom. So pretty neat stuff. All right, so what we're going to do now is we're going to talk a little bit about the night sky and some of the neat things that you can see there. Well, I hope you enjoyed that little chat about the varied topics. It's a very exciting time this August, September, October. A lot of anniversaries going on. But what I want to talk to you now about and show you is the neat thing, the greatest show on earth that's in your backyard. And I'm starting with two prominent planets that you can see. First off, you can see Jupiter, and this is September 11th. And the reason I chose September 11th is because the moon and Jupiter are right close together. That's going to make a very nice photograph because Jupiter is very bright, not as bright as the moon, but Jupiter and the moon on the evening of September 11th will be pretty cool. On the September 10th, which is the evening of Aerospace Fest, the moon will be more over here towards the west. And then the next night, September 12th, the moon will keep moving eastward and it will be like probably just slightly off of your screen. So September 11th, nice photo op with Jupiter. And then we have Saturn. Saturn is a great feature. Again, this is 11 o'clock at night, September 11th, but facing south. And Saturn, you can't miss. It's very bright, of magnitude 0.3. Jupiter, by the way, is a magnitude negative 2.9. And Jupiter will be showing its face at an angle of 50 seconds of arc, which is quite big. It's going to be in a position we call opposition, I'm going to talk about in just a moment. So we've got Saturn in the sky, and we have Jupiter. And let's take a look at Jupiter and the opposition. So what does opposition mean? Opposition means it's opposite the sun. So you can kind of see that we have the sun, of course. We don't know where the daughter went. And Earth, where we are. And then there's Jupiter. Jupiter is opposite the sun. So as the sun sets, Jupiter is going to rise and it's going to be visible all night, and that is September 26th. So the season of opposition is good a couple weeks before, a couple weeks after. You're not going to notice any major difference through a telescope during that 4-week period, but the night is September 26th. And 600 million miles away is the distance from Earth to Jupiter. And so, great opportunity, but Jupiter is great all month. Okay, then next, I mentioned to you about Saturn, and this is a great image that was taken or completed just a little while ago, a couple weeks ago, by Herb Goubert, and he's a New Hampshire Astronomical Society member, one of many who take great photographs. And he's been working on putting this series together, which takes a lot of patience. As you can see, you can look at the dates here. We're back in 2004, and you can see every year the ring's tilt changes, and that's because Saturn is in a certain orbit around the sun, Earth is in a certain orbit around the sun, and as those two orbits balance each other, there's a point, as you can see, let's see, over here, where the rings are basically edge on, like this, and then they start moving this way, the orbits, and then back this way. So you can see the last image that he just recently took in August 2022 is this one here, and we have a really good opportunity to look at the rings, the southern aspect of the rings. And with a telescope that can do 100 power or more, you should be able to see the Cassini division. There are 3 rings. There's, as coming from the outside in, there's the A ring, B ring, and yes, you've guessed it, the C ring. So the division between the A ring and the B ring, the 2 brighter rings, is this Cassini division discovered by guess who? Cassini. And so you should be able to see that. A good test for your telescope and resolution is the Encke gap, Encke, E-N-K-E, gap in the A ring, which is only 200 miles wide. But if you can boost your power with good resolution, you have an 8-10-inch telescope, you should be able to see that division as well, which is not technically actually a division. And then inside, all the way in, is the the C ring, which you really need some time to look, get your eyes adapted, maybe 200 plus power, or photographic images that are stacked on top of each other to be able to see the very faint C ring. But Saturn is a great object always to be looking at and seeing what's going on in the night sky. And I believe it's in the year 2025 that the rings, once again, are going to be very close to being edge-on to us. So they, in essence, pretty much disappear. And I did see that back in the 90s one time. Very cool. So a little bit about Saturn. So back to the night sky and such. I put up some lines here just to help us out. This is the same facing south, 11 o'clock at night, with the moon and Jupiter up here and Saturn close to the middle of your screen. But I wanted to point out some other constellations. So last month we talked about the Scorpion, we talked about Sagittarius, we did the Summer Triangle overhead in our August show, and this time I wanted to talk to you a little bit about some, you might call them delicate, very cool constellations that most people don't even know about. So what I have here is Altair, which is spelled out here for you. That is the 3rd star of the Summer Triangle. The rest, Deneb and Vega, are more overhead up this way, but Altair, just for reference, is here. And we're facing south and such. And so as you go above Altair towards the Summer Triangle, you can see this shape here. Doesn't that kind of look like an arrow? Guess what? It's the arrow. It's Sagitta, the arrow. And those stars, they're bright enough to be able to see without any difficulty, but compared to most, they're pretty faint. But that little arrow shape is Sagitta. Then here, this kind of looks like a kite. But I think also this is one of the constellations that kind of looks a little bit like what it's supposed to. It's the dolphin, Delphinus the dolphin. And then coming down more, there's 4 stars. Doesn't it kind of look like maybe the face of a horse? That's Equus, the little horse. So if we look at the next slide, we'll put some artwork up here and on this next slide. And you can see here that we've got the arrow. Here's the dolphin, and here's the face of the horse here. So take an opportunity to look for those constellations. And next slide, we're just going to take the same image, but we're just going to be looking up a little higher. So we're still same time, September 11th, 11 o'clock. Saturn is towards the south. It's at the bottom of your screen. You can see it's in the constellation of Capricorn. And then we have Aquarius, and Jupiter is hanging out with the moon on the 11th in Pisces. But as you look up overhead, you'll see what we talked about last month. You'll see Vega, Deneb, and Altair making up the Summer Triangle. And then, so in this border from Deneb down to Altair, again, you can see the arrow, Sagitta, the dolphin, Delphinus, and Equus, the face of the horse. So I hope those are interesting things for you to be able to go out and look at. They're uncommon little constellations that most people don't know about, but you've got me. And hey, don't forget, as we talk about Aerospace Fest, to finish up the show, that it is going to be September 10th, 10:30 to 4 o'clock, and you can go to starhop.com. A lot of information there, starhop.com. All the information you need, but remember, it's free. Saturday, September 10th. Kelly Beatty will be there. We're going to talk about the James Webb Space Telescope, and Mad Science will be there. There'll be activity tables, telescopes, just a wonderful day for the whole family. Aerospace Fest, so don't forget about that. And don't forget to tune in next month, October, where I'm going to be interviewing Todd J. Barber about the Voyagers that he specifically works with, the Voyager spacecraft. It's going to be a great show. Thanks for joining us. I'm Dave McDonald. You can always reach me at astromannh@gmail.com. Happy to answer your questions. I'm Dave McDonald for the Sky This Month.